November 12, 1942, Richmond, California. A 441-foot Liberty ship slid into San Francisco Bay just 4 days, 15 hours, and 29 minutes after her keel was laid, and with that splash the boundaries of industrial time collapsed in front of stunned officials, shipyard rivals, and a nation watching for proof that speed could outweigh fear on the high seas. The ship carried a name borrowed from a polar explorer, SS Robert E. Peary, but what she truly explored was a new geography of production, where sections arrived like clockwork and 1,000 hands converged to weld a vessel into being faster than anyone dared call possible the week before. At 3:27 p.m. she took the water, the culmination of prefabricated blocks and prepositioned masts, derricks, and superstructure, her wiring and paint hardened by urgency, her launch a weaponized demonstration that the war's logistics could be won not only at sea but at the slipway itself. It was not just a launch, it was a public reckoning with a simple truth: if a ship could be born in days, then attrition mathematics would tilt, convoys would thicken, and the Atlantic would become less a graveyard and more a highway for armor, grain, fuel, and hope. The scene felt orchestral rather than artisanal. Sections had been staged days in advance, boilers hoisted by mid-morning, bulkheads and the shaft tunnel stitched into place, upper deck complete by the second day, masts and superstructure by the third, and final wiring and gun platforms set before the christening, each step a bar of music in a score written for cranes and torches instead of violins and horns. The yard's choreography made visible the shift from tradition to flow. Instead of building a hull as an unbroken pilgrimage from keel to deck, the ship appeared as an assembly of 250-ton prefabricated modules, engine already seated, as if a house had been framed, plumbed, and roofed in separate fields before being lifted into alignment by mechanical grace. Reporters and rival shipbuilders had come to confirm a rumor and witness a stunt, but what the slipway delivered was a repeatable method, prefabrication, welding, and parallel work, that made the improbable a template rather than a one-time miracle. By the time the champagne frothed and the hull slid free, what had seemed an exception was revealed as a proof, the kind that makes policy change overnight and turns skepticism into a line of notebooks in a rival's pocket. The workers who stepped back from the steel were not the cloistered guild of old yards, they were migrants of necessity and conviction, women and men trained to mastery in fragments, each responsible for a seam, a plate, a cable run, a weld bead that would be repeated until hands learned the rhythm faster than a shop manual could teach it. At Kaiser's yards across the west coast, recruitment had ripped open the boundaries of who belonged in a shipyard, pulling in housewives turned welders, farmhands turned riggers, clerks turned burners, bringing them to stations designed so that repetition bred speed rather than boredom. Even the prejudice of the era could not dam the tide. Women and African American workers entered in unprecedented numbers, fought for union access, and, under pressure of war, claimed spaces on the line that became both a pay stub and an argument for a different America after the sirens went quiet. The craft traditions had been powerful for generations, but the new gospel was specialization: teach the vertical seam, the deck weld, the curve at the bow, and let 1,000 new hands learn fast, because time, not elegance, had become the currency that mattered most. The Liberty ship that thundered away from Richmond that afternoon was never meant to be glamorous, and that was the point: 11-knot stubbornness, 5 holds, a 2,500 horsepower triple expansion engine chosen not because it dazzled but because 18 companies could build it the same way tomorrow. Designed for 10,000 long tons of cargo and a range that could carry the war's appetite across oceans, the Liberty's strength was abundance, not beauty. No one writes poems to a cargo winch, but a convoy full of them can starve a wolf pack of its victories. In speeches and magazines, critics had called them ugly ducklings, but war is a terrible critic and a perfect judge. A ship that can be made quickly, sail steadily, and carry ammunition, tanks, or grain becomes handsome the moment it arrives on time. If perfection is a luxury and lateness is a sin, then adequacy multiplied by thousands is a virtue that can change a map, and on that day the map bent a little toward the Allies. The record-setting Peary did not appear from thin air. She was the end of a dare and the beginning of a standard, the culmination of a race that had tightened through the autumn as Oregon's Joseph N. Teal set a 10-day mark and Kaiser's teams in Richmond plotted how to slice that in half without starving the rest of the yard of steel, cranes, and sleep. The solution was ruthless in its simplicity: do everything you can before the keel even kisses the blocks, build the bow as a breathing room, fit the stern with its steering gear and shaft, mount the engine on its foundations where men can walk upright, not crouch, and then set the great pieces into place in a sequence that wastes no motion and takes no pride in any flourish except speed. When the keel dropped at 12:01 a.m. on November 8, the ship already existed in 100 parts, tested and waiting like actors who had memorized every line and needed only their stage directions. 4 days later, the play ended with a roar of water and rivulets of paint still drying, and the audience, some expecting a cardboard prop, found themselves clapping for a working ship that could sail in 3 more days and carry cargo in a week. What the crowd saw was not just a number on a stopwatch, it was the public birth of a method that reduced the time to sea from months to weeks, then to days when the spotlight burned brightest, a declaration that production could run at the tempo of crisis without collapsing into chaos. The median build time for Liberties would plunge toward the 40-day range in 1943 as yards embraced welded seams, standardized modules, and the choreography of parallel work, making the afternoon spectacle a forecast rather than an outlier. The logic was intoxicating and unforgiving. If a country could launch multiple ships each day, U-boat arithmetic would break, and the war's logistics corridor would begin to feel inexhaustible to those who needed it and intolerable to those who sought to sever it. In that sense, the Peary was more than steel, she was a statement that time had changed allegiances, and that the calendar itself would now fight on the Allied side. Skeptics called it propaganda, and in truth it was propaganda that worked twice. First on enemies who read the headline and understood the implication, and second on the workers who discovered that their hands could do in days what a generation had been taught required seasons. Kaiser, allergic to the word stunt, preferred incentive, and the distinction mattered to those on the night shift. Pride begins where disbelief ends, and pride is a better fuel than coffee when the whistle blows at midnight. Traditionalists in tailored coats had to blink and recalibrate, not because they disliked excellence but because excellence had changed its definition, trading artisans' perfection for a new arithmetic of adequacy multiplied by scale. In the launch's spray and echoing cheers, an industry realized that a factory could wear a shipyard's clothing and that a nation could learn a new way to count, by the day, by the hull, by the convoy that would arrive because 1,000 strangers learned to weld the same line, over and over, until the line held. Rewind to December 1940, and an unlikely shipbuilder stands at the edge of the San Francisco Bay mudflats with a contract in hand and a timetable that sounds less like prudence and more like a dare, because Henry J. Kaiser, dam builder, road maker, consummate organizer, has just agreed to deliver cargo ships at a pace that will test how fast a nation can learn under pressure. The United Kingdom is already at war and starving for hulls, and America's Maritime Commission, looking at a shipbuilding sector that had idled through the Depression, turns to an outsider willing to treat a ship not as a shrine but as a system, something that can be broken down, standardized, and taught to tens of thousands of new hands in weeks rather than years. Contracts dated December 20, 1940, split an urgent British order across 2 newborn yards, Todd Bath in Maine and Todd California in Richmond, 30 ocean-class cargo ships for each coast, identical by design so no hour is wasted reinventing a joint or arguing over a bracket when steel arrives at the gate. On the West Coast, Kaiser will provide capital, tempo, and a way of thinking, while Todd brings old-line shipyard expertise, the pairing a bridge between the craft that was and the manufacture that must be if the Atlantic is to turn from graveyard back to highway. Kaiser's credentials do not come from slips and ways but from concrete and cables, the Hoover, Bonneville, and Grand Coulee dams, and what those projects taught him is that the only religion worth practicing under deadline is flow, the alignment of people, materials, and machines so that queuing and rework die before they can grow fangs. He looks across the bay to Ford's old assembly plant at Richmond, where bodies and frames once converged on moving lines, and recognizes that while ships are too vast to ride conveyor belts, the logic of prefabrication, build sub-assemblies in their own domains where gravity and ergonomics favor the worker, can be translated into maritime without apology. Welding, not riveting, becomes central to the vision, not for romance but for speed and teachability, because a rivet crew is choreography learned over years while a weld bead, repeated to specification on the same seam day after day, can be mastered in less than a fortnight by a recruit who knows how to hold a torch and listen. Traditionalists will argue, correctly, that welding introduces new risks if steel quality falters or inspection lags, yet in a war of attrition those risks must be managed rather than feared, because time itself has chosen sides and it demands throughput. The Maritime Commission's mood in late 1940 is pragmatic bordering on desperate. In the decade behind, only a handful of U.S. merchant hulls were launched, and now the sea is swallowing tonnage faster than yards can replace it, a calculus that will doom convoys unless the build rate leaps beyond custom and into repetition at scale. That is why the Commission seeds new yards and new methods under the Emergency Shipbuilding Program, accepting that doctrine will have to chase results rather than the other way around, because schedules will not wait for sensibilities to soften. The Liberty ship, the emergency cargo carrier derived from British patterns and detailed by American firms for fast, robust assembly, is the instrument chosen for this transformation, not beautiful but obedient to a higher law, standard parts, reliable engines, and geometry that welcomes a crane's hook as if it were born to it. Gibbs and Cox refines the drawings to be built anywhere that men and women can be taught to join steel, and the plan's genius is not cleverness but restraint, fewer unique components, more interchangeable blocks, the triumph of good enough everywhere, over perfect somewhere. Richmond is selected not because it is picturesque but because it offers deep water, rail access, and empty land enough to dream in rows, 7 shipways at first, then 9, then more, each a mouth that must be kept fed with plate, pipe, castings, and people if the rhythm is to be kept and the learning curve is to bend in the workers' favor. Construction on the first Kaiser yard begins in December 1940 and the first keel for the British, the Ocean Vanguard, goes down by April 1941, a signal that the choreography from procurement to plate shop to ways is becoming a muscle the city itself can flex. Within months the Commission asks for a second yard at Richmond devoted to Liberty ships, and the logic is relentless: multiply the lines, keep the drawings simple, keep the supply base wide, and make training bite-sized so that specialization turns strangers into practitioners in weeks. Edgar Kaiser steps in as a general manager with the same intolerance for drift, and what emerges is not a single enterprise but a campus of coordinated factories, each teaching the others how to go faster without breaking the thread that holds quality together. This is where skepticism meets evidence, because the culture Kaiser seeds is not casual, it is disciplined in a way that artisans sometimes mistake for carelessness and managers recognize as design, with sequence plans that ensure heavy lifts arrive when the cranes are free and inspection gates that move to the work rather than trap it in place. Prefabricated deckhouses, bulkheads, and machinery foundations are built on their sides or upside down for better weld access, then rotated and staged like actors waiting for cues only a small army of riggers and planners can hear, and the dividend is not only speed but sanity. People work standing up, with light and leverage, improving the weld and the welder at the same time. The philosophical turn is unmistakable: a yard becomes a system, a schedule becomes a promise, and craft becomes a set of repeatable motions captured in jigs and fixtures so that the same seam looks the same on Tuesday as on Friday, no matter who holds the stinger. When critics grumble that ships should be born in sequence, Kaiser replies, by actions more than words, that sequence is a choice when parallelism is available, and that the ocean cannot ask whether a deckhouse was welded in a bay or beside a keel if both meet the drawing. Even before Pearl Harbor, wartime logic is reshaping Richmond's horizon, and when the war comes, the yard's purpose hardens into something that sounds like audacity to those who do not live by quotas and manifests: build faster than the enemy can sink, accept the homeliness that comes with haste, and put your faith not in a signature hull but in the convoy. The Liberty's 11-knot plod and cavernous holds are not defects but decisions, because speed in shipbuilding has been redefined as ships per day, not knots per hull, and the convoy's geometry favors the many over the nimble. As Richmond adds shipways and neighboring yards in Portland and Vancouver spin up, the network effect emerges. More yards mean larger supplier pools mean fewer bottlenecks, and fewer bottlenecks mean the learning curve steepens in a way no single yard could achieve alone. By mid-1942 this architecture of production is visible to anyone walking the perimeter fence, a map of cranes and rail spurs and staging pads arranged to advance time itself, forcing it to spend fewer nights inside each hull. Kaiser's advantage is not that he knows ships better than shipbuilders, it is that he knows work better than almost anyone and designs organizations that let average people perform above average by eliminating every gratuitous burden between them and a good day's output. The Richmond enterprise treats schedule as a living thing, measuring not just days to launch but the cycle times of weld procedures, the arrival cadence of plate and shapes, the readiness of sub-assemblies to meet a crane, metrics that root out superstition and make improvement less a suggestion than an inevitability. Skeptics inside the Commission who blanch at the speed begin to see the safety net beneath it: inspection regimens adapted to welds, materials controls sharpened to reduce brittle fracture risk, and rework loops designed to catch trouble upstream instead of at sea, and the argument shifts from whether to how. In that shift lies the heart of Kaiser's philosophy: results reform doctrine, and once results are public, doctrine follows with surprising grace, because even traditionalists understand victory when they see it. By the time Richmond's first British hulls are sliding down their ways and the Liberty lines are humming, the outlines of the revolution are sharp enough to sketch in chalk, standardize ruthlessly, train specifically, stage intelligently, and let parallelism do what sequence cannot when the calendar is the enemy. What begins as an outsider's gamble rapidly becomes a national method, and even those who dislike its aesthetics find themselves persuaded by its arithmetic, because the only thing uglier than an ugly duckling is an empty pier in Liverpool or a desert tank battalion waiting for a ship that never left the slip. Kaiser does not win the argument by speeches, he wins it by launches, and in late 1940 through 1941 the launches begin to feel less like miracles and more like the heartbeat of a system that has finally remembered how to scale. The promise that began as a contractor's signature in December becomes a discipline that will carry through the darkest months of convoy warfare, precisely because it makes an ancient industry feel new without discarding the one thing tradition is best at preserving, the obligation to deliver when lives depend on it. Rewind to December 1940, and an unlikely shipbuilder stands at the edge of the San Francisco Bay mudflats with a contract in hand and a timetable that sounds less like prudence and more like a dare, because Henry J. Kaiser, dam builder, road maker, consummate organizer, has just agreed to deliver cargo ships at a pace that will test how fast a nation can learn under pressure. The United Kingdom is already at war and starving for hulls, and America's Maritime Commission, looking at a shipbuilding sector that had idled through the Depression, turns to an outsider willing to treat a ship not as a shrine but as a system, something that can be broken down, standardized, and taught to tens of thousands of new hands in weeks rather than years. Contracts dated December 20, 1940, split an urgent British order across two newborn yards, Todd Bath in Maine and Todd California in Richmond, 30 ocean-class cargo ships for each coast, identical by design so no hour is wasted reinventing a joint or arguing over a bracket when steel arrives at the gate. On the West Coast, Kaiser will provide capital, tempo, and a way of thinking, while Todd brings old-line shipyard expertise, the pairing a bridge between the craft that was and the manufacture that must be if the Atlantic is to turn from graveyard back to highway. Kaiser's credentials do not come from slips and ways but from concrete and cables, the Hoover, Bonneville, and Grand Coulee dams, and what those projects taught him is that the only religion worth practicing under deadline is flow, the alignment of people, materials, and machines so that queuing and rework die before they can grow fangs. He looks across the bay to Ford's old assembly plant at Richmond, where bodies and frames once converged on moving lines, and recognizes that while ships are too vast to ride conveyor belts, the logic of prefabrication, build sub-assemblies in their own domains where gravity and ergonomics favor the worker, can be translated into maritime without apology. Welding, not riveting, becomes central to the vision, not for romance but for speed and teachability, because a rivet crew is choreography learned over years while a weld bead, repeated to specification on the same seam day after day, can be mastered in less than a fortnight by a recruit who knows how to hold a torch and listen. Traditionalists will argue, correctly, that welding introduces new risks if steel quality falters or inspection lags, yet in a war of attrition those risks must be managed rather than feared, because time itself has chosen sides and it demands throughput. The Maritime Commission's mood in late 1940 is pragmatic bordering on desperate. In the decade behind, only a handful of U.S. merchant hulls were launched, and now the sea is swallowing tonnage faster than yards can replace it, a calculus that will doom convoys unless the build rate leaps beyond custom and into repetition at scale. That is why the Commission seeds new yards and new methods under the Emergency Shipbuilding Program, accepting that doctrine will have to chase results rather than the other way around, because schedules will not wait for sensibilities to soften. The Liberty ship, the emergency cargo carrier derived from British patterns and detailed by American firms for fast, robust assembly, is the instrument chosen for this transformation, not beautiful but obedient to a higher law, standard parts, reliable engines, and geometry that welcomes a crane's hook as if it were born to it. Gibbs and Cox refines the drawings to be built anywhere that men and women can be taught to join steel, and the plan's genius is not cleverness but restraint. Fewer unique components, more interchangeable blocks, the triumph of good enough everywhere over perfect somewhere. Richmond is selected not because it is picturesque but because it offers deep water, rail access, and empty land enough to dream in rows, 7 shipways at first, then 9, then more, each a mouth that must be kept fed with plate, pipe, castings, and people if the rhythm is to be kept and the learning curve is to bend in the worker's favor. Construction on the first Kaiser yard begins in December 1940 and the first keel for the British, the Ocean Vanguard, goes down by April 1941, a signal that the choreography from procurement to plate shop to ways is becoming a muscle the city itself can flex. Within months the commission asks for a second yard at Richmond devoted to Liberty ships, and the logic is relentless: multiply the lines, keep the drawings simple, keep the supply base wide, and make training bite-sized so that specialization turns strangers into practitioners in weeks. Edgar Kaiser steps in as a general manager with the same intolerance for drift, and what emerges is not a single enterprise but a campus of coordinated factories, each teaching the others how to go faster without breaking the thread that holds quality together. This is where skepticism meets evidence, because the culture Kaiser seeds is not casual, it is disciplined in a way that artisans sometimes mistake for carelessness and managers recognize as design, with sequence plans that ensure heavy lifts arrive when the cranes are free and inspection gates that move to the work rather than trap it in place. Prefabricated deckhouses, bulkheads, and machinery foundations are built on their sides or upside down for better weld access, then rotated and staged like actors waiting for cues only a small army of riggers and planners can hear, and the dividend is not only speed but sanity. People work standing up, with light and leverage, improving the weld and the welder at the same time. The philosophical turn is unmistakable: a yard becomes a system, a schedule becomes a promise, and craft becomes a set of repeatable motions captured in jigs and fixtures so that the same seam looks the same on Tuesday as on Friday, no matter who holds the stinger. When critics grumble that ships should be born in sequence, Kaiser replies, by actions more than words, that sequence is a choice when parallelism is available, and that the ocean cannot ask whether a deckhouse was welded in a bay or beside a keel if both meet the drawing. Even before Pearl Harbor, wartime logic is reshaping Richmond's horizon, and when the war comes, the yard's purpose hardens into something that sounds like audacity to those who do not live by quotas and manifests: build faster than the enemy can sink, accept the homeliness that comes with haste, and put your faith not in a signature hull but in a convoy. The Liberty's 11-knot plot and cavernous holds are not defects but decisions, because speed in shipbuilding has been redefined as ships per day, not knots per hull, and the convoy's geometry favors the many over the nimble. As Richmond adds shipways and neighboring yards in Portland and Vancouver spin up, the network effect emerges. More yards mean larger supplier pools mean fewer bottlenecks, and fewer bottlenecks mean the learning curve steepens in a way no single yard could achieve alone. By mid-1942 this architecture of production is visible to anyone walking the perimeter fence, a map of cranes and rail spurs and staging pads arranged to advance time itself, forcing it to spend fewer nights inside each hull. Kaiser's advantage is not that he knows ships better than shipbuilders, it is that he knows work better than almost anyone and designs organizations that let average people perform above average by eliminating every gratuitous burden between them and a good day's output. The Richmond enterprise treats schedule as a living thing, measuring not just days to launch but the cycle times of weld procedures, the arrival cadence of plate and shapes, the readiness of sub-assemblies to meet a crane, metrics that root out superstition and make improvement less a suggestion than an inevitability. Skeptics inside the commission who blanch at the speed begin to see the safety net beneath it: inspection regimens adapted to welds, materials controls sharpened to reduce brittle fracture risk, and rework loops designed to catch trouble upstream instead of at sea, and the argument shifts from whether to how. In that shift lies the heart of Kaiser's philosophy: results reform doctrine, and once results are public, doctrine follows with surprising grace, because even traditionalists understand victory when they see it. By the time Richmond's first British hulls are sliding down their ways and the Liberty lines are humming, the outlines of the revolution are sharp enough to sketch in chalk, standardize ruthlessly, train specifically, stage intelligently, and let parallelism do what sequence cannot when the calendar is the enemy. What begins as an outsider's gamble rapidly becomes a national method, and even those who dislike its aesthetics find themselves persuaded by its arithmetic, because the only thing uglier than an ugly duckling is an empty pier in Liverpool or a desert tank battalion waiting for a ship that never left the slip. Kaiser does not win the argument by speeches, he wins it by launches, and in late 1940 through 1941 the launches begin to feel less like miracles and more like the heartbeat of a system that has finally remembered how to scale. The promise that began as a contractor's signature in December becomes a discipline that will carry through the darkest months of convoy warfare, precisely because it makes an ancient industry feel new without discarding the one thing tradition is best at preserving: the obligation to deliver when lives depend on it. Prefabrication turned the shipyard inside out, shifting the center of gravity from the slipway to a constellation of specialized shops where bow and stern, bulkheads and decks, deckhouses and machinery blocks were built simultaneously and staged like actors awaiting their cues under the tallest cranes on the waterfront. In Richmond, entire superstructures and deckhouses advanced down movable lines in a dedicated prefabrication plant, assembled inverted for easier downhand welding and then rotated, cut into transportable sections, and ferried to the hull for final joining, compressing weeks of crouched work into days of efficient lifts and runs of cable and pipe laid at waist height before ever touching the ways. The result was a yard that behaved less like a single workshop and more like a synchronized organism, where each bay's output was precisely timed to a crane and a rail spur, and where the slipway became the last stage of a long choreography rather than the only theater in which a ship could be made. This was the practical meaning of modularity: reduce the hull to repeatable blocks, teach teams to master their one block to a standard, and let the cranes knit the pieces together with speed that felt as shocking to rivals as it felt natural to a workforce trained to the rhythm of flow rather than the traditions of sequence. The cranes themselves, led by revolving, whirly giants capable of 360-degree swings and heavy lifts, gave the yard its mechanical tempo, picking entire deckhouse slices, double bottom units, and machinery foundations and dropping them on marks chalked by fitters who knew that time saved at elevation was time a convoy would gain at sea. Where older yards had asked men to work inside half-built cages, Richmond asked the crane to do the climbing, moving 20 to 80-ton sections in minutes and letting welders finish joints in open light rather than under cramped shadows, a change in posture that showed up instantly in cycle times and inspection results. Rail lines laced the yards with a second circulatory system, bringing plate to panel lines, moving finished modules to staging pads at the head of the ways, and ensuring that a newly launched hull would be followed by a new keel within a day because the next ship already existed in parts waiting within reach. In this environment, the slipway's bottleneck loosened, because the work that once clogged it upstream now arrived finished, verified, and ready to be joined, turning the launch from a relief into a routine and allowing the yard to measure progress by lifts per shift as much as by days to launch. A Liberty's anatomy was deliberately drawn to welcome this treatment: long, straight runs for welding, large unobstructed holds for cargo, and deckhouse geometries amenable to being built on their sides and stacked like tiers of a theater before being sliced into craneable pieces for transport and final assembly. The standard design, EC2, SC1, made interchangeability the default, spreading identical details across every participating yard so that suppliers could scale up and specialists could improve in place without suffering the penalty of unique fittings at every turn. Prefabricated double bottoms, fabricated upside down in jigs to lock geometry and speed downhand welding, moved by trailer and rail to the ways where they could be mated to side shells and bulkheads as if the ship had been ordered in kit form and assembled under floodlights on a schedule measured in hours. By the time a hull stood high on the blocks, its deckhouse floors already knew where staterooms would bolt, its foundations already matched machinery footprints, and its wiring runs had been pulled flat on benches rather than threaded through a labyrinth, a quiet revolution in ergonomics as decisive as any change in metallurgy. Parallelism was the yard's superpower, and it ran deeper than steel. While welders closed seams in a double bottom, electricians pulled cable in a deckhouse bay and machinists torqued foundation bolts in a machinery block that had never seen salt spray, each discipline insulated from the other's delays and yet bound to a shared tact enforced by cranes and staging schedules. This separation of domains eliminated the old fights for floor space inside a half-finished hull and converted waiting time into working time elsewhere, so that the only cues that mattered were the ones at the crane, and even those were managed by sequence plans that treated lift slots like runway clearances. Inspections followed the work rather than trapping it, with fixed jigs and gauges embedding quality into the setup so that welders inherited consistency and inspectors could verify more, faster, with less argument about edges and fit because the fixture had already settled the question. And when rework did appear, it could be contained within a module bay rather than rippling down an entire line of tasks, the functional equivalent of compartmentalization in damage control but applied to time instead of flooding. The payoff was measurable and public. Construction times that had begun in the 200-day range plunged as prefabrication matured, with average builds around 42 days by 1943 and launches occurring at the rate of 3 per day across the program, a cadence that would have sounded like fiction in 1941 and yet became routine by mid-war. The median figure tightened further in some yards as learning curves compounded, reflecting not merely hustle but a systematic reduction of variance, jigs, fixtures, and standardized weld procedures turned craftspeople into high-reliability teams whose best day slowly became their everyday. Across all yards, the fact that 3 Liberty ships were being finished daily in 1943 meant not just more hulls but a surplus of options for convoy planners, who could now schedule with confidence rather than hope, knowing that a delay at one yard would be washed out by the constancy of many. In that arithmetic, the skeptics discovered that stunts replicated become policy, and that a slipway becomes a metronome when the rest of the factory keeps time. Perhaps the most elegant scene in this orchestration was the machinery drop, because it inverted a century of discomfort by marrying fit and finish to gravity rather than asking men to carry both on their backs inside a hot engine room. Engines, boilers, and auxiliaries were set on their foundation structures in open bays, aligned to datum points, piped and wired where a foreman could see every hand at work, and then lifted as integrated blocks onto the hull, eliminating the weeks of contortion that had once defined the job. The effect was not just speed but safety and quality, because mistakes caught in open light could be corrected without the penalties that multiply inside a steel box, and every successful lift reinforced the yard's discipline in counting down to launch with fewer surprises. The day of the drop felt like a filmed ritual, chalk marks, taglines, hand signals to the crane operator, except that, unlike rituals, it left behind a working engine room in hours rather than a worksite that would linger for weeks. Even the soft infrastructure conspired to keep the hard work fast. Rail timing, crane assignments, sub-assembly buffer stocks, and shift handovers were tuned to avoid starvation at the ways, because a crane without a module to lift is as wasteful as a welder without power. The prefabrication plant had its own assembly lines, complete with roller beds and rotation rigs, turning the deckhouse into a literal moving product that gained walls, piping, and even furnishings as it advanced, like a ship within a shipyard learning to be complete before it ever met its hull. These floating assembly lines were not metaphors but mechanisms, and their existence meant that the launch often brought a ship to the outfitting pier with a surprising amount of work already behind it, narrowing the gap between splash and service. With each iteration, the line got smoother, because standard parts multiplied and special cases were hunted down in drawings and vanquished in change orders that gave the crane fewer reasons to pause. Standardization's national dividend was a supplier base that could finally breathe in rhythm with the yards, producing repeat parts that fit everywhere, allowing procurement officers to place orders across multiple yards without pleading for exceptions that turned inventories into museums of one-offs. The Maritime Commission's insistence on a single, serviceable, easily built class meant that lessons learned in Baltimore could pay off in Richmond or Portland within weeks, lowering both costs and tempers by replacing debate with revisions stamped and distributed to every bay that needed them. That same standardization hardened training into curricula that matched the work, letting schools teach a welder exactly the seam that would be needed on Monday and confidently predict the station where that person would stand by Friday, a promise only mass production could keep. As the months turned, the country learned to think in assemblies and lifts and tack times, and the shipyards learned to think in convoys and cargo tons delivered by a calendar that had chosen to favor those who could manage flow. By early 1943, prefabrication and parallelism were no longer experiments but the marrow of emergency shipbuilding, the unglamorous magic that allowed a gray hull to move from chalk lines to christening in the span of a pace cycle and then vanish into a convoy column large enough to stare down attrition. The cadence, 3 ships a day, roughly 6 weeks per hull in many yards, seemed to break the war's logic, which had begun with the enemy's premise that sinkings could outrun launches, a premise now undermined by factories that behaved like orchestras playing the same score in different cities. The slipway crowds who cheered each launch were not applauding miracles, they were applauding a method that had taught cranes to keep time and taught thousands of new hands to place steel in space as if it had always been meant to fit there. And somewhere beyond the breakwater, the math moved, because when prefabrication and parallelism run on schedule, the ocean loses some of its power to frighten calendars and begins, stubbornly, to deliver. The revolution ashore began with people, a tide of newcomers who poured into the yards with calloused hands and untested confidence, filling stations that had never been open to them and turning a quiet company town into a roaring, 24-hour city whose heartbeat was the shift whistle and whose lifeblood was a workforce assembled from every corner of the country. Richmond swelled from a pre-war population of roughly 23,600 to more than 93,000 by September 1943, a transformation so abrupt that streets, schools, and clinics strained just to keep pace with names and faces arriving off trains Kaiser had chartered and subsidized to bring labor west at the speed steel demanded. Recruiters, 170 of them, combed farm towns and mining camps from the South and Midwest to the far edges of the plains, offering training, wages, and the promise that specialized work could be learned quickly enough to matter before the war's calendar turned the page again. The result was a city remade by motion. Families took rooms in hastily built developments, bus routes multiplied, and the night shift turned neighborhoods into constellations of light, because in Richmond the clock now belonged to the shipways and the people who fed them. No change felt more immediate, or more subversive to the old order, than the arrival of women into skilled shipyard roles on a scale the nation had never attempted, their coveralls bearing names like welder, burner, shipfitter, and expediter rather than the job titles wartime propaganda pretended were their only lane. By 1944, women accounted for about 27% of the Richmond shipyard's workforce, roughly 24,500 people, while making up more than 41% of all welders and nearly a quarter of all craft roles, numbers that no longer felt like exceptions but like a new normal under floodlights and crane booms. North along the Columbia River, Vancouver's Kaiser Yard counted 10,600 women shipbuilders in 1944, another datum in a growing ledger that recorded how swiftly skill followed opportunity once the door was opened and the training pipeline was real. The work was not symbolic, it was specific, repetitive, hard, and essential, and each bead laid and plate fit underlined the fact that the calendar would henceforth be kept not by custom but by competence learned fast, checked often, and paid in the coin of ships launched on time. The other barrier that bent under pressure was race, as African Americans, long blocked from high-wage industrial work, entered Richmond's yards in numbers that rewrote pay stubs, shop rosters, and, slowly, expectations, with more than 10,000 black workers on the rolls by 1944 and a city whose black population rose from 1% in 1940 to 13.4% by 1950. The hiring wave drew migrants from Texas, Oklahoma, Arkansas, Mississippi, and Louisiana, attaching Southern accents to Northern California skylines and confronting unions and foremen with the urgent arithmetic of war. A ship does not care who joins its seams if the weld holds and the convoy sails. In crews and classrooms, integration advanced unevenly, contested by some, defended by others, but the sheer necessity of throughput made the workforce a truer meritocracy than peacetime had allowed, and the yards became a lived argument that talent, given access and tools, outperforms prejudice on any schedule that matters. That lesson, stamped into thousands of shift changes, was as durable as any seam, because it migrated home with the people who learned it and did not forget. Housing and child care were not amenities here, they were production systems by other names, because no yard can run without roofs and relief for families whose days were measured in whistles and whose nights were often owned by second shifts. Atchison Village rose in 1941 as one of several worker housing solutions in Richmond, a neighborhood where the walk to a bus stop or the shipyard gate was a calculable part of the day rather than a gamble, and where a new mother could count on returning to a job because child care existed as policy, not as charity. Across the Columbia, the Vanport housing project began in late 1942 on 650 acres of floodplain, a city built almost overnight to stabilize the labor force for Kaiser's Portland and Vancouver yards and to relieve a housing market so tight it threatened to send trained workers back on the same trains that had delivered them. Within months, Vanport became Oregon's second-largest city, 35,000 to 40,000 people, proof that industrial policy includes streets and schools when the nation decides that time is a weapon and that people are the powder that drives it. The work itself demanded a health system that did not yet exist, so the shipyards built one, stacking first aid stations at the yards, a field hospital within blocks, and a flagship facility in Oakland into a three-tier network designed not for theory but for throughput, preventive care, and the readiness that high-risk labor requires. The Permanente Richmond Field Hospital opened on August 10, 1942, financed by the U.S. Maritime Commission and run by Dr. Sidney Garfield, starting with 10 beds and scaling to 160 by 1944, a humble, single-story structure that catapulted into significance because it was placed exactly where the injuries and illnesses would occur and because it served a prepaid health plan that welded medicine to the workday. By August 1944, 2% of Richmond shipyard employees were enrolled in the Permanente Health Plan, a voluntary, prepaid model that bundled group practice with on-site facilities and made care an expectation rather than a gamble, a forerunner of the modern HMO that would, after the war, extend to families and persist as one of the country's largest non-profit systems. In a city where production could not wait for an ambulance from far away, the plan turned minutes into policy and proved that readiness in medicine, like readiness in manufacturing, comes from designing systems around the time it takes to act, not the time it takes to wish. Inside the gates, training programs matched the scale of hiring, translating craft into curriculum so that a recruit could arrive on Monday a stranger to a torch and by Friday take a place on a vertical seam with a badge, a procedure, and a mentor one station away to check the first runs before the crane arrived. Specialization was the pedagogy: teach the weld positions the yard needs most, drill the sequence until muscle memory outran nerves, and embed inspection at the station so that success was measured in immediate corrections rather than future regrets, a pattern that made new welders productive in weeks instead of years. These classrooms, some formal, many improvised beside jigs and fixtures, treated knowledge like any other tool, to be placed exactly where the job required it and replenished as the tack time tightened and the next hole's deadline moved closer. What seemed to outsiders like a miracle looked, up close, like coordination, a city, a yard, and a clinic all tuned to the same metronome and all bent toward the same purpose, which was to turn people into capacity and capacity into ships without sacrificing the human beings who made the number possible. The social fabric that emerged from this intensity was neither accidental nor sentimental, it was operational, a mesh of bus routes, cafeterias, clinics, schools, and pay windows that kept the line continuous and the people resilient under hours that would have broken a community without such scaffolding. In Richmond census ledgers and in Vanport's hastily erected streets lay a message to future planners: when a nation chooses speed, it must choose systems that honor the bodies delivering it, because efficiency without dignity collapses under its own contradictions. The wonder of the wartime West Coast was not only that 3 ships could launch in a day, it was that the hands which launched them could find a doctor on the same block, a classroom for a child, and a bus that arrived in time for the next shift, each piece reinforcing the others until the sum felt inevitable. And when the war ended, the memory of that integration, work, health, housing, training, did not dissipate, it congealed into institutions and expectations, into the conviction that a factory town could also be a place where the people who built the machines were treated as the first machines a just society must maintain. What began as spectacle hardened into schedule, and the yard's learning curve wrote itself in numbers so stark they felt like a new language. The first Liberty holes took roughly 230 days, but by 1943 the median had plunged to around 41 to 42 days, and launches were happening often enough to turn calendars into convoy timetables. Man-hours told the same story in a different dialect, falling from early averages near 1.4 million per ship to under 500,000 by 1943, a compression of effort so dramatic that even skeptics conceded the process had become its own proof. At scale the effect was unmistakable: 3 new Liberty ships were launching daily at peak, and the cadence felt less like a sprint than a drumbeat, steady enough for planners to rely on and relentless enough for enemies to fear. Those first-year figures, 244 days for Patrick Henry and an initial pattern hovering around 230 days, now read like the naive confidence of an industry taking its first steps in a faster world, because within months the alignment of prefabrication, welding, and parallel work compressed both time and risk into something yards could repeat on command. By 1943, the country had a method: average construction times near 41 to 42 days, with the most efficient yards tightening further as jigs, fixtures, and standardized weld procedures eliminated variants that used to masquerade as craft. In some analyses of the nationwide program, labor hours clustered around 0.5 million per hull by late 1943, with the best lines occasionally approaching the mid-300,000s, a performance ceiling reached when planning, supply, and inspection learned to keep pace with the cranes. The numbers were not vanity, they were strategy, because a convoy full of 11-knot workhorses can beat attrition if hulls arrive faster than torpedoes can subtract them, and that is exactly what the Liberty program's cadence achieved by the middle years of the war. Total output crested at 2,710 Liberty ships, an industrial act so outsized that it became its own kind of ordnance, the tonnage of steel and cargo carving lanes across oceans where maps had recently marked only losses. What mattered was not that any single ship was beautiful but that all of them were ready, because adequacy multiplied by thousands defeats perfection arriving too late to matter. Under the skin of those statistics lived the mechanics of learning. Standardization froze the design, specialization simplified training, and prefabrication turned the slipway into the final assembly station rather than the only place a ship could be built. Welding speed and teachability converted bulkheads, deckhouses, and double bottoms into modules that advanced in parallel and met at the crane, allowing cycle times to shrink without demanding heroics from exhausted crews inside half-finished compartments. Inspection moved with the work rather than against it, embedding gauges and checks at the station so quality became a property of setup and sequence, not a prayer offered at the end of the line. Costs mirrored the curve, stabilizing around $2 million wartime dollars per hull even as wages and material pressures clenched elsewhere, a rough equilibrium that reflected repetition's quiet economies in a design built to be built. The narrow spread of standard parts reduced scrap and hurry-up rework, and the choice of the simple, oil-fired plant kept propulsion from becoming a bottleneck that would have devoured every gain made in the hull. Where earlier programs pivoted on bespoke fittings and signature machines, the Liberty turned on interchangeable pieces and procedures disciplined enough to be taught, checked, and repeated at the speed of necessity. If outsiders called the ships crude, the yards called them honest, because crude is a slur for what standardization looks like when you're forced to choose between a convoy that sails and a masterpiece that waits its turn. The Maritime Commission's emergency shipbuilding program accepted that trade on day one, and the yard's results made it policy: build what crews can operate, what suppliers can replicate, and what cranes can lift without surprises, then do it again tomorrow. In that logic lay the center of gravity for the learning curve itself, because production accelerates most when decision-making becomes a memory rather than a meeting. Even economists took notice, because the Liberty program offered pristine data for an old idea, that repetition plus feedback yields nonlinear productivity gains until a new design or disruption resets the clock. Studies measuring the pace of improvement found that part of the observed gains came from true learning and part from capital investments aligned with that learning, evidence that factories improved fastest when tools and people learned together. The transition to Victory ships even proved the reset rule in practice, denting efficiency as yards relearned details for a design that, while better at sea, broke some of the Liberty's hard-won production reflexes. None of this meant the program was flawless, only that it was honest about the cost of speed and disciplined about fixing its own mistakes at source rather than at sea, a habit that saved both time and lives. The brittle fracture scares of early welded hulls forced changes to steel specs, details around hatch corners, and the addition of crack arresters, improvements that quickly flowed through drawings to every bay that touched the metal and shored up confidence where it mattered most, on the winter Atlantic. Learning, here, was measured not just in hours saved but in fractures that did not propagate, a quieter metric but no less decisive for a class designed to cross cold oceans without complaint. When the pace reached 3 liberties per day in 1943, the feat landed with a heavy ordinariness that only systems can produce, because nothing feels inevitable until it has been rehearsed enough to bore the people who make it happen. Museum captions that summarize the drop from 230 to 42 days sound like magic tricks, but in the yards it looked like punctual deliveries to staging paths, an inspection stamp where it belonged, and a crane arriving on time to find a module ready rather than a promise waiting for tools. The Peary's 5-day sprint reminded the public that the ceiling could be pushed in a pinch, but the line's average was the true sword, cutting through U-boat arithmetic by refusing to slow down. By late 1943, average labor hours that once grazed 7 digits had settled near the 500,000 mark, and the program's best lines flirted with figures a third lower, proof that operations discipline and factory ergonomics could wring waste out of a ship as surely as a designer could wring speed from a hull. In that range, the difference between a good week and a bad one often came down to planning, not heroics, and to whether the necessary parts and people met at the right place at the right time without tripping over one another. The yards learned to count not just in days but in handoffs, and the handoffs got cleaner as the year deepened, which is how a nation unfamiliar with this tempo in 1941 became astonishingly good at it by 1943. The lesson did not fit on a banner, so the program wrote it on hulls instead, thousands of gray silhouettes whose existence proved that learning curves are not secrets but systems, their slopes steepened by standardization, specialization, and the humility to improve the next lift before the last one cooled. What Allied sailors saw from the bridge was a column that kept its dates. What yard workers saw from the dock was a line that kept its promises, and in wartime those two perspectives are the same thing said in different weather. The Liberty's triumph was never that it was the best ship, it was that it was the best taught ship, and teaching, done properly, turns time into an ally, which is how you beat an enemy who thought he had stolen the calendar. By the fall of 1942, the West Coast shipyards had turned speed into a kind of public theater, and the curtain rose in Portland when Oregon Shipbuilding launched the Liberty ship Joseph N. Teal just 10 days after keel laying, a feat that put a bright number on the bow and a shock into rival yards up and down the coast. Newspapers blared the record, the launch drew crowds, and the message was unmissable: if a 10,000-tonner could go from chalk lines to splash in a week and a half, then the calendar itself could be bent to the war's needs. The Teal's speed was not an accident but a culmination of habits learned at pace: prefabrication, standardized fittings, practiced crane choreography, and it electrified a competition that Henry Kaiser had quietly encouraged between his Portland and Richmond teams. Records, once thought to belong to myth or rumor, were now stamped into shipyard diaries with dates and times, and the race shifted from whether it could be done to how much faster the next yard would dare. At Richmond, the gauntlet did not land on empty ground, it landed among planners and foremen who had been sharpening their own tempo since summer and who read the Teal's 10 days as both a dare and an instruction. Kaiser's managers answered the provocation in the only language that counted: sequencing, staging, and more prefabrication than anyone in the yard had yet attempted, and they set their eyes on a goal that sounded like bravado until it became a calendar entry: half the Teal's time. The selected hull, number 440, would carry the name SS Robert E. Peary, and behind the name stood a method refined for a sprint, with deck units consolidated, machinery foundations built and aligned off-hull, and every lift rehearsed against the clock. The yard did not whisper its intent, it published it to cranes, crews, and inspectors, because a race is a promise as much as a plan, and promises have a way of forcing obstacles to move. At 1 minute past midnight on November 8, 1942, the Peary's keel kissed the blocks and the countdown began, the yard moving with a tempo more like a switchyard than a foundry as pre-built pieces rolled toward the ways in an order that had no room for improvisation. The bottom shell unit went first, then the inner bottom under the boilers, followed by transverse bulkheads that closed the hull into stiff, workable geometry before the sun had a chance to warm the steel. By mid-morning the boilers were set, the shaft tunnel and more bulkheads followed, and before a second midnight, the upper deck was complete, an audacity made possible only because whole segments had been built like furniture in a shop rather than like sculpture on a scaffold. Day 3 brought masts, derricks, and superstructure. The final day sealed wiring, welding, painting, the forward gun platform and inner stack, each step tallying toward a precise finish rather than a vague hope. The clock stopped at 3:27 p.m. on November 12 to 4th days, 15 hours, and 29 minutes after the keel laying, when the Peary slid into San Francisco Bay, a launch cheered by the people who had made it inevitable and watched by rivals calculating what parts of this feat could be made routine. The numbers did not end at the splash. 3 days later, on November 15, the ship was delivered for service, setting a second record at 7 days, 14 hours, and 32 minutes from keel to delivery and making clear that the Sprint was not a stage set but a working vessel ready to carry a wartime load. In an industry that had trusted in months, the sight of a ship leaving the outfitting pier less than 8 days after its first plates were laid struck like a verdict on what factory logic could do when given cranes, rails, and a single unifying deadline. And in the same breath, the yard proved the pace was not chaos by laying the next keel within minutes of the launch, an act as ceremonial as it was operational in announcing a line that refused to fall behind. To make time give way, Richmond had doubled down on modularity, using more prefabrication on hull 440 than on any prior Liberty in the yard, consolidating deck units that once came in 23 pieces into just 7 large assemblies complete with piping, hatch structures, and winch foundations. Machinery foundations and blocks were aligned in the open air and lifted into place with their geometry already settled, an inversion of the old misery of building an engine room in cramped heat that saved days precisely because it saved labor from performing acrobatics. The effect was cumulative, every reduction in piece count yielded a lift saved, a fit-up simplified, an inspection made easier to perform on the ground instead of at a height. The point was not simply to go faster once, but to learn where speed lived so that some portion of it could be kept when the banners came down and the yard returned to its normal, if normal could still be a word, in the 40 to 50-day range. Publicly, the Peary carried 2 labels at once, and both of them told the truth in different registers. Critics called it a stunt ship, a publicity thrust designed to show the world and the U-boats that American yards could outbuild attrition, while Kaiser insisted it was an incentive ship, a record meant to lift morale and set a practical horizon for the possible. The launch speeches and newsreel flashes were not the point was what spread through the bays the next morning, a feeling that the stopwatch was not just for the newspapers, that time itself could be trained to behave when a yard treated it like any other resource to be scheduled and consumed. If propaganda, it was propaganda with payload, because workers who have seen 4 days turn into a ship are not easily persuaded that an extra week must be tolerated for the same work tomorrow. And to the extent the word stunt implies waste, the delivery 3 days later answered with steel and steam that the line could hold its own argument. The record's other truth was its limit. Even Richmond admitted that such pacing could not be sustained continuously, not with steel allocations, crane availability, and upstream suppliers constrained by the same war that demanded output without end. But a limit is not a flaw, it is a fact to be respected while the lessons are banked, and the lessons from the Peary, bigger prefabricated units, cleaner lift sequences, earlier machinery setting, tighter inspection choreography, bled into the yard's baseline and then into other yards that sent observers to watch the impossible get timed. The average at the Permanente yards hovered near 50 days for a Liberty under ordinary priority, and even that ordinary had become extraordinary by the standards of 1941 because the very architecture of work had been redrawn. Where once all questions were resolved on the ways, now the ways were the last place a problem wanted to be, and that was a quiet revolution no headline could fully capture. What the Teal began with 10 brash days, the Peary answered with 4.5, and between them lay the essence of the wartime shipyard's pride, a rivalry that served a purpose larger than bragging rights and a method that could be taught, borrowed, and made hum in cities that had never before built ships at this pace. The New York Times had already taught the country to read launch records like box scores by late September. By mid-November, Richmond's slipway gave the standings a number no one had predicted when the year began. And yet, after the cheering, the most consequential sound remained the same, the clank of keel blocks being set again, because speed is a headline only once, but cadence is a victory repeated until the enemy's arithmetic fails. In that sense, the Peary was not just fast, it was instructive, a teacher that left behind a lesson the yards could put to work with every hull that followed. Adequacy became a strategy the moment the Liberty class proved that a 441-foot, 5-hold cargo ship cruising at about 11 knots and carrying roughly 10,800 deadweight tons could be built so steadily that planners began to treat launches like a schedule rather than a hope. The performance envelope was humble by design, oil-fired boilers feeding a rugged triple-expansion engine, long straight runs for cargo and welds, and deck gear arranged for fast loading, but in a war of supply lines, reliability and volume mattered more than grace, which is why the Liberty's ordinariness turned into power at scale. At peak cadence the nation was finishing multiple hulls per day and ultimately delivered 2,710 Liberty ships across 18 American yards, an industrial chorus singing the same part loudly enough to drown out attrition math that had once favored U-boats. What headlines called workhorses, the convoy called essential, and in the measured language of tonnage and days, the class earned its nickname by doing exactly what it was asked to do, thousands of times, without demanding the spotlight for any single ship. Raw cargo numbers gave the abstraction weight. A Liberty could be packed with about 2,840 jeeps, enough to stretch a train for miles if loaded 9 to a flat car, or carry on the order of 440 light tanks, or hundreds of personnel carriers, or hundreds of millions of rounds of small arms ammunition boxed and ready for war. Those comparisons, rail miles and acres of armor, translated the ship's 5 cavernous holds into something a dockworker could imagine and a quartermaster could count, turning 10,800 deadweight tons into steel, rubber, and propellant that would decide a battle's second week as surely as guns would decide its first day. The same hull that hauled grain one voyage could haul fuel, trucks, pipe, or crated aircraft the next, because the design prioritized open volume and robust gear over specialization that would have stranded capacity when needs shifted faster than drawings could be revised. In the ledger of logistics, that flexibility was another form of speed, the kind that moves at the pace of a manifest instead of a propeller. Convoys stitched this tonnage into strategy, because a 10, 11-knot ship in company is safer than a faster ship alone, and the entire Allied routing apparatus evolved to shepherd columns of Liberties toward ports where their cargoes could matter on time rather than merely arrive intact someday. Routing officers counted weather, wolf packs, air cover, and port readiness, but their most valuable constant was abundance, knowing another column of gray hulls was days behind the one being plotted on the wall map. That constancy turned the Atlantic from a gauntlet into a highway by 1943, not because the sea became kind but because the schedule became relentless, and relentless schedules are hard for torpedoes to defeat. In that sense the Liberty was a policy as much as a ship, a commitment to make enough the decisive adjective. Roles multiplied as the class proved itself, and necessity pushed conversions that the drawings had anticipated in outline but not in detail, roughly 225 Liberties became troop ships, their holds and 'tween decks fitted for hundreds of soldiers, while others served as tankers, hospital ships, repair vessels, picket ships, or specialized carriers tailored to the next campaign's appetite. The cargo version remained the backbone, winches creaking, booms swinging, hatches yawning over stacked crates and vehicles, but the class's simplicity made adaptation easier and faster, which is why the same silhouette could show up with different interiors across theaters without confusing crews or parts depots. Even when pressed into troop service, the ships moved at the same 11-knot plod, which was slow in miles per hour but brisk in miles per month once convoys and port cycles synchronized. In war, endurance and predictability often masquerade as slowness until the map reveals what steady lines can achieve. By 1944, the Victory ship entered as the faster, larger successor, better engines, higher speed, more capacity, but it did not erase the Liberty's logic so much as extend it, proving that the same prefabrication and parallel assembly principles could be taught a new tune without losing the beat. Victories were designed with peacetime utility in mind, while Liberties had been designed as an emergency answer to an emergency question, yet both sailed on the same idea that standard parts and repeatable processes are kinder to a nation's nerves than bespoke brilliance in a crisis. Where the Liberty wrote adequate and abundant, the Victory added faster, and together they filled a pipeline that became, in the Park Service's phrase, America's lifeline in war. Even so, the Liberty silhouette remained the emblem of the proposition that a good enough ship, built often enough, can move history. The statistics that tend to be tucked into captions were, in truth, the story: crews of a few dozen merchant mariners augmented by Navy armed guard for guns and radio, ranges around 17,000 miles on a fill, and handling qualities that rewarded seamanship rather than speed, all wrapped into a package that could be run, repaired, and returned to sea in ports far from the yards that birthed it. None of this sounded glamorous to anyone who had ever swung a cargo boom in sleet, but it was precisely the ordinariness that made the class a better fit for a global supply chain than a hotter, fussier ship that would choke on its own requirements. When losses bit, replacements arrived, when routes shifted, manifests changed, and when campaigns opened, columns formed with enough predictability to let armies plan, which is the highest compliment logistics can pay to strategy. The Liberty's virtue was that it could be counted on, and in a war decided by countable things, that virtue had the weight of armor. The ugly duckling moniker stuck because the ships looked boxy and plain, but the crews who sailed them and the planners who scheduled them learned to hear the insult as backhanded praise, a reminder that beauty in wartime is measured by arrivals, not lines. Journalists noted the speed records and the cranes, but mariners remembered the feel of a steady 11 knots under a gray sky, the slow swing of a convoy turn, and the relief of a harbor whose cranes moved as if they had been waiting for exactly this ship all week. The work was repetitive, the watches long, and the routes dangerous, yet the class did what it promised so consistently that its predictability became a weapon of its own. That reputation outlasted the paint, and long after the shooting stopped, the argument remained: adequacy, multiplied, wins. If the Liberty had a secret, it was only this, that a design frank about its limits, speed, grace, glamour, could be paired with a production system frank about its strengths, standardization, teachability, flow, and together they could accomplish the one-trick war respects, which is to show up on time with exactly what was asked. The class's range and cargo plan did not make headlines, but they filled warehouses, depots, and staging grounds, and that is where campaigns are either born or stillborn. Convoys and routing orders tightened the weave until distance and danger became management problems instead of verdicts, and inside that weave the Liberty found its place as a node you could rely on rather than a name you would remember. In the long arithmetic of World War II, the Liberty ship was a digit repeated across 1,000 sums, and the totals it made possible outweighed every critique of the parts that built it. The home front became a machine for making time when Richmond learned to build not only ships but the city that built them, a mesh of housing, buses, classrooms, clinics, canteens, and pay windows that kept people moving toward their stations and back again without wasting the minutes a convoy would later need at sea. The scale of the experiment was visible at street level: defense housing climbing out of mud within months, bus schedules stretching past midnight, cafeterias open around the clock, and its purpose was practical rather than picturesque: remove friction from daily life so that labor could be turned into launches without breaking the bodies doing the work. Where peacetime industry treated such amenities as charitable extras, wartime Richmond treated them as tools, each one measured against a clock and a quota, and each one justified by a keel that dropped on time. Start with the roof over a worker's head, because housing is the first shift of any industrial day. Atchison Village, begun in 1941 under the Lanham Act, became the city's durable answer to transients and long commutes, a permanent, high-quality development designed to be close enough to the yards that a bus ride could be predicted like a lunch break. Built as defense housing by the new Richmond Housing Authority, Atchison Village paired sturdier construction with a neighborhood plan that fostered cohesion and safety, a place where workers could sleep, families could stabilize, and absenteeism could be tamed by proximity rather than pep talks. Unlike many wartime projects that vanished with victory, the village endured, eventually becoming a resident-owned cooperative, an afterlife that testifies to the wisdom of building communities as if they would be needed after the sirens stopped. Childcare, too, became a production system by another name, because a welder with no one to watch a child is a welder who cannot keep a schedule, and Henry Kaiser treated that fact as operational rather than sentimental. The Maritime Child Development Center opened in 1943 as one of roughly 35 nursery school units in wartime Richmond, federally supported, designed with progressive pedagogy, and equipped with health services, art classes, hot meals, and even family counseling, all so that parents could work and children could thrive rather than simply wait out a shift. By mid-war, Richmond's child care network supported daily attendance of about 1,400 children, a number that maps precisely onto the afternoon whistle and the night bus, and reflects both the magnitude of women's entry into shipyard work and the city's decision to make that entry sustainable. In Washington, Kaiser argued openly that child care, clinics, shopping, and recreation were essential industrial supports the government itself should finance, so that production would not depend on private charity or wishful thinking about domestic labor that had already moved to the yards. Health care was the third leg of this scaffold and the one that changed American medicine. The Permanente Richmond Field Hospital, opened August 10, 1942, sat at the center of a three-tier system with first aid stations in the yards for immediate needs and a main Permanente hospital in Oakland for the cases that could not wait for a change of shift. Run by medical director Sidney Garfield under Kaiser's Permanente Foundation and financed with U.S. Maritime Commission support, the field hospital began with 10 beds, expanded to 160 by 1944, and operated as an integrated, prepaid service that followed workers from shop floor to ward without sending them across town for basic care. By August 1944, 2% of Richmond shipyard employees had joined the Permanente Health Plan, the first voluntary group plan of its scope to combine prepayment, group practice, and substantial on-site facilities, making medicine a scheduled part of the workday rather than a gamble to be managed after hours. The effect on productivity was as real as any new crane, injuries treated promptly, illnesses caught early, and workers returning to the line faster because care had been designed to keep pace with manufacturing rather than lag behind it. The plan's inclusiveness mattered, too, because the waiting room became one of the first places in wartime industry where enrollment was open regardless of race or background, bending practice toward equity even when law lagged behind. In a city where African American migration had surged to fill industrial roles long denied in peacetime, and where women's badges now read welder, burner, and crane operator, the clinic's voluntary enrollment and prepaid model meant access was governed by work and membership rather than gatekeeping at a receptionist's desk. After the war, the plan widened to include families and evolved into Kaiser Permanente, the nation's largest nonprofit HMO by 1990, proof that systems built for speed in crisis can become systems built for dignity in peace. The field hospital, humbly modernist and single-story under rationing's constraints, closed in 1995, but the model it pioneered never did, because it had been forged in an environment where time and fairness could not be traded off without losing ships. None of this scaffolding, housing, child care, clinics, would have mattered without the connective tissue of training, transit, and canteens, the thousand small decisions that turn services into schedules. Richmond's 170-person recruiting apparatus fed classrooms designed to teach specialized tasks in the exact positions the yard required, so that a new hire moved from weld school to a marked spot beside a jig as predictably as a module moved from bay to crane. Bus lines multiplied to link housing clusters with staggered shift times, flattening the peaks that break timetables and leave cranes waiting for crews, while cafeterias extended hours to keep calories aligned with workloads instead of forcing families to navigate closed kitchens and empty diners. The result was not indulgence but orchestration, a city that made good work more likely by refusing to make daily life harder than the work itself. The moral dimension of this efficiency revealed itself in small scenes that workers remembered long after yards went quiet, a child fed and safe while a mother finished a weld, a sprain set by a nurse down the block instead of across the county, a bus that arrived through rain because the timetable was treated like a contract. These were not benefits, in the narrow, modern sense. They were components of a logistics plan for human beings, translated into throughput by the steady hands they protected and returned to the line. When critics worried aloud that such services were soft luxuries in hard times, the yards answered the way factories answer every philosophical question, by showing the line running on time and the launch schedule holding fast under stress. In that answer lay a redefinition of efficiency, one that counted people as the first machines a just system must maintain. The Richmond ecosystem also remade expectations, because inclusion ceased to be an abstraction when daycare rosters and clinic lines displayed a workforce that looked like the nation rather than a guild. Women's share of the shipyard workforce, more than a quarter by mid-1944 in Richmond, was not sustained by slogans but by services knit into the day so tightly that leaving the job meant giving up a system that had learned your child's name and your bus stop as well as your badge number. Black workers, drawn west by the promise of wages and work that matched their abilities, found in the plan's voluntary enrollment and the city's federated services a measure of predictability that peacetime had rarely offered, a platform from which to argue, by example, that equity improves output as surely as it improves lives. In shipyards and neighborhoods, the home front taught a lesson the slipway alone could not: systems that waste people are systems that waste time. Even the failures and floods of the wider region, Vanport's later disaster across the Columbia, could not erase the immediate wartime logic that had justified building entire cities around shipyards. When you concentrate production, you must concentrate care, or the very speed you seek will devour itself. Richmond avoided the worst of those fates because many of its wartime structures were built to last, its clinic sited within walking distance of 1,000 emergencies, and its housing planned for permanence rather than tents in all but name. The National Park Service's preservation of sites like the Field Hospital, Child Development Centers, and Atchison Village now reads as both commemoration and instruction, a reminder that the fastest systems are often the ones that treat people as the critical path rather than a cost center. In museum placards and neighborhood co-ops, the argument endures: build the city that builds the ship, or accept that the ship will not be built on time. By war's end, when membership in the health plan dipped and federal child care funding dried up, some pillars of the system shrank, as if peacetime had decided it could afford to forget what crisis had taught so well about the economics of dignity. Yet the institutional DNA persisted: group practice, prepayment, integrated clinics, and the conviction that services aligned to work improve both people and production, carried forward by Kaiser Permanente and by communities that refused to demolish everything they had built under pressure. The enduring parts of Richmond's experiment became a primer for planners who understood that the shortest distance between a contract and a launch might run through a cafeteria, a bus depot, and a nursery classroom. And if anyone doubted that such soft systems could stiffen a nation's resolve, they needed only to stand beside a slipway at shift change and count how many hands arrived on time because an entire city had decided to help them do so. When the war ended and the ways fell quiet, the Liberty ship did not recede into nostalgia so much as it dissolved into method, leaving behind a blueprint for how complex things could be built quickly, safely, and at scale. When drawings were standardized, work was divided into teachable tasks, and cranes stitched prefabricated blocks into ships with the calm confidence of routine. The class itself, born as an emergency answer, outlived its crisis in two forms: steel and system, because thousands of hulls served on into commercial life while the ideas that shaped them became the grammar of post-war shipbuilding across the world. If wartime had proven that adequacy multiplied defeats perfection delayed, peacetime proved that the tools of adequacy, welding, modularity, flow, and inspection at the station, could become the permanent language of an industry that never again wanted to be caught unprepared. In this sense, Liberty ships were not only cargo but curriculum, teaching that time can be engineered when design, training, and layout are honest about human limits and industrial strengths. The repairs made to early welded hulls were more than patches; they were textbooks in metallurgy and fracture mechanics that would permanently alter how designers think about steel in cold water and about the way a crack travels through a structure that has no rivet lines to stop it. Investigations into brittle fracture, square hatch corners acting as stress concentrators, low-toughness steel hardening into treachery in winter seas, weld details propagating rather than arresting cracks, produced a suite of corrections from rounded hatch corners to crack-arresting straps and better steels, changes that migrated from emergency bulletins into norms and codes. The crisis forced an upgrade of practice that advanced understanding of toughness, notch sensitivity, and stress concentration, and those lessons moved from shipyards to classrooms and back again until a new discipline, fracture mechanics, could be felt in drawings as much as in lab notes. What began as an industrial emergency matured into an engineering vocabulary that protected ships long after the last liberty was laid down. A few survivors kept the memory hot with steam rather than stories, and none more visibly than SS John W. Brown in Baltimore and SS Jeremiah O'Brien in San Francisco, the two Liberty ships still operational and open to the public as living museums. The Brown's post-war life carried her from merchant service to years as a vocational high school training ship in New York before preservationists brought her to Baltimore in 1988, where she now sails with volunteers who practice the maintenance of memory as if it were a duty station. The O'Brien, preserved substantially in her wartime configuration, made a 1994 pilgrimage through the Panama Canal and across the Atlantic back to Normandy for the 50th anniversary of D-Day, the only Liberty and the only original invasion ship to return under her own power to the beaches where she had once worked 11 round trips in 1944. Visitors touring her engine room still watch a triple expansion engine breathe like a metronome, a living exhibit that compresses a century of propulsion pragmatism into the tempo of pistons and valves made to be understood as well as admired. Abroad, the method hardened into dominance as Japan took block construction, the wartime U.S. innovation of assembling large welded sections, and pushed it further than anyone had dared, enlarging the blocks, lifting them with 100 to 300-ton gantry cranes, and moving outfitting work earlier in the process so that cabling, piping, and systems arrived with the steel rather than chasing it. Japanese yards systematized zone outfitting, breaking ships into zones with parts lists and time deliveries so materials met blocks at exactly the moment a crane and a crew were ready, a choreography that fused aircraft-style production control with welded block assembly and statistical process control to vaporize idle time. The infrastructure followed the method, Goliath cranes, large dry docks, and layouts that gave sub-assemblies room to breathe, while continuous improvement programs standardized parts and procedures to squeeze variance out of every weld and lift. By the late 1960s, Japanese yards delivered on a scale and at costs that made their processes global benchmarks, an ascent signaled in trade journals and shipowner order books that read Japan as a synonym for lots of ships, built well and fast. South Korea took the baton in the 1970s, building shipyards and ships at Ulsan simultaneously and adopting heavy-lift block construction and large dry docks as the default architecture of a national industry that would become the world's largest within a generation. Hyundai Heavy Industries Ulsan Complex, 9 dry docks, Goliath cranes looming over a coastal campus, turned modular assembly and high-completion blocks into a way of life, delivering VLCCs and container ships with a cadence that rewrote production records and made the yard skyline a map of modern shipbuilding itself. The trick was the same truth Liberty yards had learned at lower tonnages: do more work where gravity and ergonomics favor the worker, raise blocks only when they are as complete as possible, and keep materials arriving in timed waves so cranes never wait for parts and crews never wait for cranes. In Ulsan, statistics and silhouettes lay the proof that the wartime grammar of American emergency yards had become the global language of commercial shipbuilding. Back home, the Liberty program's significance remained anchored not just in totals but in technique, 2,710 hulls overall and the acceleration from 230-day builds to averages near 42 days, because those numbers describe an organizational shift as much as a production triumph. The National Park Service calls the Liberty and Victory ships America's lifeline in war, and the phrase captures both the tonnage and the tempo. A lifeline is only a lifeline if it is strong and on time, and the Liberty's strength was its ability to be both, repeatedly. That reliability shaped more than shipyards. It seeped into the way managers across industries described flow, learning curves, and standard work, a vocabulary of adequacy and abundance that became a compliment rather than an insult when lives and deadlines coincided. If factories thereafter looked more like orchestras, sections practicing separately, than uniting under a single conductor's clock, it is partly because of what the cranes at Richmond and Portland taught the nation about rhythm. The brittle fracture chapters, once feared, became an ethical and technical inheritance: improve the steel, soften the corners, arrest the crack, and adopt welding codes that make quality a property of preparation rather than post-mortem. Those fixes worked their way into standards and inspection regimes, and they crossed into other fields: bridges, pressure vessels, offshore structures, whenever cold, stress, and time threatened to conspire again. In each case, the Liberty's emergency matured into someone else's prudence, the wartime improvisation codified so thoroughly that it began to look like common sense. The ships had been criticized as crude, the methods became careful, which was always the point. Standing on the Brown's deck in Baltimore or the O'Brien's in San Francisco, the line from wartime to now is not abstract, it is a handrail polished by visitors, reciprocating engine breathing below, and the knowledge that these hulls are survivors in steel of a larger survival in method. They carry veterans' memories and docent stories, but they also carry a broader testimony, that systems built for crisis can leave behind virtues sturdy enough for peace, and that a country's industrial confidence can be taught and relearned as surely as a weld can be practiced until it is clean. The Liberty ship's final lesson is a quiet one: build the system that makes good work likely, then repeat it, because repetition is not the enemy of greatness, it is how greatness is made visible in time. In that repetition, the ships that once seemed ordinary turned into something rare, proof that the fastest way to change the future is to standardize the part that works and keep it moving until the job is done.